Welcome to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a paper titled LineRides, which introduces a way for robots to learn extreme stunts from simple lines. Normally, teaching a robot to perform a jump or a flip requires incredibly complex reward functions that are hard to design. Traditional methods often rely on imitating human or animal movements, but those do not always work for unique robot designs. The researchers developed LineRides to allow a robot to acquire these skills without needing a person to show it exactly how to move every joint. Instead, a user provides a spatial guideline, which is basically a path the robot should try to follow in the air or on the ground. The robot used in these experiments is called the Ultra Mobility Vehicle, or UMV. It is a custom-built, two-wheeled robot that resembles a bicycle but has a special articulated module on top. This module, nicknamed the Boing, contains most of the robot's mass and can move up and down to create momentum. By shifting this weight at the right time, the UMV can perform highly dynamic and acrobatic maneuvers. To make this work, the LineRides framework uses the user-provided line to define the desired motion. However, because humans might draw a line that is physically impossible for a robot to follow perfectly, they introduced a margin parameter. This margin gives the robot the flexibility to deviate from the line just enough to stay upright and follow the laws of physics. Another challenge is timing, as the line itself does not tell the robot how fast it should be going at any given point. To solve this, the system uses the robot's traveled distance along the line to track its progress instead of a clock. The researchers also use something called key orientations to tell the robot which way it should be facing during a stunt. For example, in a hop, they can specify that the robot should land on its back first by setting a specific angle at the end of the line. This level of control allows for fine-grained motion details that make the stunts look smooth and intentional. The robot is trained in a simulation first, where it learns to switch between a normal driving mode and a specialized stunt mode. In driving mode, it responds to joystick commands just like a remote-controlled car. But once a button is pressed, it transitions seamlessly into stunt mode to execute the pre-planned line. The results are impressive, featuring 5 distinct stunts including a mini-hop, a large hop, and a 3-point turn. They even trained the robot to perform a left-hand drift turn and a full vertical backflip in simulation. The guidelines for these stunts were created using different methods, including simple hand-drawn sketches and mathematical curves. What is truly fascinating is that this framework is not limited to just bicycle robots. The team also tested LineRides on a 4-legged quadruped robot, successfully teaching it 5 different stunt skills. This proves that the method is general enough to work for various types of robot bodies. To recap, LineRides transforms a simple sketch into a complex robotic maneuver by handling physics and timing automatically. This means that in the future, we might be able to program robots just by drawing what we want them to do. It removes the need for expert-level coding or expensive motion capture data for every new task. The future of agile robotics looks more intuitive than ever, thanks to researchers connecting human intent with low-level control. Thanks for watching Summarize Science, and stay tuned for more amazing tech simplified.